Hi my all students. Today I am discussing about insertion and deletion operation of single linguist. In my last slide, last video, I already discussed about the how to create the linked list, why linked list is needed. If you want to watch that portion first, then you will get the link in the description box of this video and you can check it from there. And because after understanding this portion, then you can understand today's portion. So if you want to clear that concept, first watch that video and then watch this one. Okay, first I want to give thanks to all of my viewers who are viewing my previous videos. I really happy to get so many valuable feedback from them. I am really thankful to all of you, and the same things I am telling again. If you like my lecture, you think that it is helpful to you and for your friends or other family members or relatives, then please like and share it. And if you have any query, any remarks for on our lecture, then there is no problem, there is not a issue. You can just comment me and I will try to clarify the concept. If you want any other subject, computer science other subject or other topic lecture video, then also you can message me or you can comment here, then I will try to fulfill your request. I already got some requests. If for getting lectures from for getting my more lectures, you can subscribe this channel, Computer Science Lectures for Makauti students. Actually these lectures are helpful not only for Makauti students, the students of computer science in any university. And to get the notification, please turn on the bell icon. Okay, now today I will first discuss how we can insert a new node to a existing linked list. This linked list is already existed. Now I have to insert a new node in this linked list. Okay, so this is the linked list. We already know from our previous video that how to create linked list, and this way we have created this list. Now I will discuss that how to create a node into a linked list. So I am showing it on a previous on already given a linked list. This linked list is already existing, and I am adding a new node here. Now we can add a node in different position. We can add a new node in the first position or in the last position or in the any other middle position. Where we want to insert, we can insert. We will just allocate memory for the node and we will link it in any position where we want to insert the node or we want to insert the element. Okay, now suppose here first we want to insert a node at the first position. That means we want to insert an element before 10. 10 is our first element here. Now we want to insert an element before 10. So first we need to create a node. Suppose Q is our node which is allocated memory location 4000. This is linked list. In anywhere where the free memory is available, we can allocate. So suppose we are getting free memory at 4000 location, and we have allocated it for the node. Now we will insert our element. Suppose 5 is our element and insert it in the data portion of the node. Okay, now what is the rule? this rule is that if 4000 makes our first node, that means we will insert the node 4000 before the nodes on 1000. Okay, so what will be the logic? This 4000 will point the node 1000 and head will point 4000. Then only we can link this node or we can insert this node before 1000. So our logic is that to insert at front q of next. This is our q node, which node we already which node we want to insert at the first position. The node is named as, or the node is marked as q. So q is the node. Now we will want to insert this node before 1000. So q of next, that means this portion, next portion will store the address of 1000. So q of next will be head. Head contains 1000. So this 1000 value will be stored here. Okay. Then what will happen? This link will be created. That means now q node stored the address of this node. So this link will be created now. Now our next logic is head equal q. That means head will store the address of new node q. So 4000 will be stored here and this node will be created, and similarly this link will be broken. So now 4000 points the node q and q points the nodes 1000, and this way this is the linked list. So here we have inserted the first new node q at the first position. Similarly, if you want to insert the node at any other position, suppose we want to insert a node after 10 or before 15, that means our third position, first, second, third, or 0, 1, 2. What you want to say, you can say. We can start from 0, 0, 1, 2, and we can start from 1, 1 to third position. So after 10 before 15, that means in third position we want to insert a node. Suppose this is a node, we have created memory location for, now this is the q new node, and we want to create the memory at the location 5000. Now we want to insert element, our element is 13, so 13 is inserted in this node which is created on 5000 location. Now what will be our logic? We want to insert this node after 10 and before 15. Okay, so what will be our logic? Now first of all we have to input our position, in which position we want to insert our node. I is our position, insert the position, which position, suppose the POS is the position variable. Suppose we want to insert here, as we are starting from 0, 0, 0, 1, 2. That means in position 2 we want to insert our new node. So, and I is our position variable. Suppose position variant or position indicator. So I equal 0. Now start node start t. So t is a start node type pointer which points the node. Here this is our first logic is that if head equals to null. Suppose there is no node. So this is a blank linked list. There is no node, head value is null. That time what will happen? We can create only one node and linked it by head. So this will be just simple as linked list creation. So when we want to insert the first one node only, that time when head value is already null, the logic will be that logic will be similar to the inserted font. Q of next equal head and head equal q. When head value is null, that means there is no more head, there is no more node. Okay. This is only the if condition, and our else part is that suppose there is already some nodes and we want to insert our new node at position 2. So what will be the logic? T equal head, that means T points head, that means T point the position whose address is stored as a head value. So T will point 4000, that means T will point the node which is created at 4000 location. Now we will use a loop, while loop, which is iterated up to going to the proper position where we want to insert our node. So our logic is that while T of next not equal to null, T of next not equal to null, and I less than pos minus 1. Pos is our position. Here the value of pos is 2. So now first our logic is that I value is 0, I equals 0. Now we will checking in this way. T of next not equal to null. T point this node which is created on 4000. So T of next is what value? 1000. 1000 is the T of next value. So T of next not equal to null. First condition is true, and the next condition is I less than pos minus 1. Now I value is 0, pos value is 2. So 0 less than 2 minus 1 is 1. So 0 less than 1. So both condition is true. So what will we do? T equal T of next I plus plus. So T will go T of next. T of next is 1000. So T will come in this position. So now T will point this node. Now T will point this node which is created at 1000 location. Okay, and I value will be also incremented. It is now 1. Okay, now again we will check our while loop. T of next not equal to null. Now the value of T of next is 2000. So which is not, this is not equal to null. So our first condition is again true. Now I less than pos minus 1. Now I value is 1. 1 less than pos minus 1. 2 minus 1 equal 1. 1 less than 1. No. So our this condition is false. So our both condition is not true. First one is true, but last one is false. So this condition of while loop is not satisfied, not true. So we will go here. So now our T is in this position, and here we want to insert our new node. So this is our Q and this is our T. So what will we want to do? Now this node will insert here after 1000. This 5000 node will the node which is created at 5000 memory location will insert after the node which is created at 1000 memory location. So what will we do? Now here this is our T of next which is 2000. Now this node will point this node which is created at 2000 location. So this value will be stored here. So Q of next will be T of next. So 2000 will be stored here, and this link will be created. Now T of next, this one will point this one which is created at 5000 location. So this node will point this node. So T of next will be Q. So 5000 will be stored here, and this link will be created, and similarly that link will be destroyed. So in this way we can insert this node at the second position. Okay. Similarly, if we want to insert our node at the last position, end position, what will be the logic? Suppose we have created our node here. The memory location, suppose 6000. 6000 memory location is allocated for this node. This is our new node Q. Now I want to insert here an element. Suppose 35 is this element which I stored in this node. Now I want to insert this node at the end position of the linked list. So what will be the logic? The same rule will be there. The difference is that in same way t value will be come here. First t value is here. In same way t value is come this position. Okay. In same way we will traverse our t and it will come in this position, and when it will come in that position 3000, that time what will be the logic? While t of next not equal to null, but here t of next equal null, so this condition is false. Okay, t of next equal null, so this condition is false. So we will insert our node here. So q of next equal t of next. Q of next is q of next will be t of next. So t of next is here null. So null will be stored here, and t of next will be q. That means this node will point our end node. So t of next will be 6000 and this link will be created. This is the total position how to insert a new node in our existing linked list. Okay, this is the three scenario. In this three scenario we can insert a new node at beginning, at begin position or at front position, at end position, and in middle any other position we can insert our node. Okay, next we are interested to see how to delete a node. Insertion is over. Now the deletion portion. How to delete a node from existing linked list. This is our linked list. Now I want to delete a node. What is the logic? Suppose I want to delete the first node. This first node I want to delete. So what will be the logic? First I am taking in this way. T is our structured node type pointer. Already I saw at the previous slide struct node pointer T. So T is our structured node type pointer and T equal head. That means T points the first node head. T out our first node, because head value is 1000, head point the first node and T equal head, so T point the first node head. Now their logic is that if head equals to null, suppose there is no node, head value is null, that means there is no node, so we will simply print that nothing to delete. Else what will be the logic? Head equal T of next, because we want to delete first node. So now head will point second node, this node. So head equal T of next. What is the value of T of next? 2000. So 1000 will be replaced by 2000 and this node will be created. And we will use free function for delete, malloc and calloc for allocate memory location, and free function for delete memory location. So free T, that means this link will be destroyed and this node will be deleted. Okay, in this way we can delete the first node from a linked list. Similarly, we can delete last node. How to delete the last node? This is the logic. Now in same way, T equal head. So now head value is 2000. So head point this node. This is our at present scenario. This is our first node which is created on 2000. So T point the node which is on 2000. Okay. Now here we want to delete our last node. That means this node which is created at 6000 memory location. So what will be the logic? This portion is same. If head equals to null, that means there is no node in our linked list, so nothing to delete. Else, if there is a condition, else if T of next equals to null. Now our T is here and T of next equals to null. If this value is null, that means there is only one node in this linked list. So that time what will be the logic? Suppose t points the node 2000, so t of next equals to null, that means this value will be null. So there is only one node in our linked list. So that time what will be the logic? Head of head equal to null. If we want to delete this only node, then there is nothing. So this is an empty linked list. So head value will be null at that scenario. So and we will free t at that time. Okay. So if this is if suppose t is only one node and t of next is null, in that scenario if we delete this node, so that time head value contain the value null, that means there is no node. Clear? And this is one condition, that's why we have used else if. Else in else condition there is nothing, that scenario there is so many nodes, not more than one nodes in our, we have more than one nodes in our list. That time there is this one is our logic. T of next, t is here, t points the node 2000, t of next, that means t of next 3000, of next that is 6000, not equal to null. Yes, this is 6000 not equal to null. So t equal t of next. So t value will be come here in this position. Okay. So from this node it will point this node. Now again we will check t of next, which is 6000, of next, which is nothing but null. So t of next not equal to null, this condition is false. So now what will be the logic? We will free t of next. We will free t of next. So this node t is here and t of next, that is 6000. The node which is created as 6000 memory location will be deleted. So this node will be deleted and the value of t of next will be nothing but null, because now this t node is our end node, because that next node which was in 6000 memory location now deleted and the memory location is also freed. Okay, this is the logic for our delete a node from linked list. This is our I already discussed how to delete the first node and how to delete the last node. Next logic is one more scenario of deletion, that is, suppose we want to delete a number, but we don't want to delete through position, we want to delete through number. That means we want to delete this number 20, this element 20 or this item 20. We want to delete 20 from our list. So what will be the logic? Start node, start t, start to 1. Here we have taken two traverse pointer t and t1. Now what is the logic? First, head equals to null, nothing to delete. This is the similar already I discussed in previous slide. Now else t equals to head. So t equals to head, that means t point the node which is whose address is stored in head value. So 100. Okay. So t point 100. Now মানে আমার 100 মেমোরি লোকেশনে যে নোটটা আছে তাকে টি পয়েন্ট করছে। এগেন নেক্সট one is T1 equal T of next. So T1 will be T1 equal T of next. So T of next is 2000. So T1 will point the node at memory location 2000. তার মানে কি হচ্ছে T1 2000 memory location এর যে নোডটা আছে তাকে পয়েন্ট করছে। Now if T of data equals to item, suppose we T of data is here 10. Now if we are searching for 20, if we search for 10, that time T of data equals to item, this condition will be true. যদি আমরা 10 কে সার্চ করতাম তাহলে আমার এই কন্ডিশনটা ট্রু হতো। So that time what will be the logic? Head equal T of next and free T. That means we will delete this node and head will point this one. T of next is nothing but 2000. So head equal T of next. That means head contain the value 2000 and the link will be created here. Okay. But here we want to delete the element 20. So we will follow this logic. So this condition is false. T of data equals to item? No. Because T of data is 10 and we want to delete 25. Not 10. Sorry, we want to delete 20, not the 10. So else, while T of next not equal T1 of next not equal to null. T1 is here. T1 is T is at 10. T points the node which is created at 1000 position and T1 points the node which is created on 2000 memory location. Okay. যেটা মানে আমার প্রথম নোডটাকে T পয়েন্ট করে আছে আর সেকেন্ড নোডটাতে T1 পয়েন্ট করে আছে। Now what we are checking? T1 of next not equal to null. Now the value of T1 of next is 3000. So it is not null. Our condition is true. And T1 of data not equal to item. The T1 of data is 15 and we want our item is 20. So this condition is also true. Both condition is true. So T1 equal T1 of next. Now T1 is T1 point 2000 and we are doing that T1 equal T1 of next. T1 of next is 3000. So T1 will be go in this position. Okay, and T equal T of next. So T was 1000 and it will go here 2000. So T is now 2000 memory location and T is points 2000 memory location and T1 points 3000 memory location. Okay, again we will check this while loop. T1 of next not equal to null. Now T1 of next is 6000. So it is not null and T1 of data not equal to item. T1 of data is 20 and we are also searching for 20. So our data is 20. So this condition is false. So we will go, our control will go out from while loop. Control amar while loop theke আমরা বেরিয়ে আসবো। Now what is the condition? If T1 we don't know why we are out from while loop. Maybe first condition is false or second condition is false. তাই তো যখন আমরা এই স্টেটমেন্টটাতে আসছি তখন তো আমরা জানতে পারবো না যে কেন আমরা মানে আমরা while loop থেকে বেরিয়ে এলাম কেন, কোন কন্ডিশনটা ফলস হয়েছে। So we have to check. So if T1 of data equals to item. Now T1 of data is 20. T1 of data equals to item. This if condition is true. So T of next equal T1 of next because we need to delete this node. So T of next. What is T of next? If we delete this node, so what will be the scenario? This node which is created on 2000 memory location will point this node which is created on 6000 memory location. So T of next equal to T1 of next. So T of next is 3000 and T1 of next is 6000. So now we will assign 6000 in place of 3000. So 6000 will be assigned here and this link will be created and then free T1. also we will delete this note. Okay, so in this way we can delete the note which contain our searched element. Okay, this is another scenario of deletion. Okay, today my discussion is up to date. Okay, in my next lecture I will talk about doubly linked list and some limitation of singular linked list. Okay, so this is the references you may follow. Thank you.